Good morning, everyone, and welcome to our 8th webinar on industrial use of HPC. I am Maria from the ATP from HPC office. I will be the host of this session, and my colleague Pascal, she will help us with the questions today. We have with us Sai Narasimhamurthy from Seagate and Jean-Philippe Nominet from CA. They will moderate the session. And we have invited Thierry Collet and Jean-Paul Martineau from Thales and Gerd Büttner from Airbus. They will present their experience, how they use HPC. Before we start, here are a couple of useful information. This webinar is recorded. You will receive the link to the recording together with the slides of the presentation on Monday. This webinar is in listen-only mode. You can communicate, ask questions from us, from the organizers and the speakers via the control pane, as you can see here. You can find this GoToWebinar control panel on the right-hand side on your own computer desktop. So you can ask questions or send us remarks at any time during the presentations. We will answer you online, and we will also answer the questions for common interest during the Q&A session. Here is the agenda. Sai will start with the introduction soon. Then Thierry and Jean-Paul will show some examples and next steps, how Thales is using HPC. And Gerd will present the future challenges using HPC at Airbus. We will close the webinar with the Q&A session, and we plan to finish at 12 today. Sai, I give the floor to you.
Thank you.
Please. Oops.
Yeah, this is fine. So just a quick introduction. So my name is Sai Narasimhamurthy, and I'm in the steering board of ETP4HPC, and I hold the position of VP of Industry, and I also chair the Industrial User Working Group. So next slide, Maria. Thank you. So just a quick summary of what ETP4HPC is. I think many of you already know about this, but it's always good to give a sort of a give a recap of what we actually do. So we are an industry-led think tank, and we want to promote HPC research and innovation, and we want to support European competitiveness in this area. And we have a strong focus on all kinds of technologies, not just both hardware as well as software. And we are committed to developing a very vivid, very strong HPC ecosystem along this entire value chain. And we are a private, independent, non-profit association, and we have more than 100 members now. And the member base has been continuously increasing, and we are very excited about this. And from 23 countries, and about 40 SMEs and 40+ research organizations and large EU companies and international companies. And if you look at the spectrum of all the people in all the members in ETP4HPC, we have like ISVs and advanced HPC users, such as many of the people that are here with us today are guests, technology suppliers, vendors, service providers. So it's a very bubbling, exciting community. So we are also a private member of the EuroHPC joint undertaking, along with our partners, Big Data Value Association. And primarily, our deliverables consist of the HPC strategic research agendas that is fed into upcoming work programs and things like that. And we have multiple handbooks of EU HPC projects. So I just also want to let you know that we have a very exciting new initiative called the Continuum initiative, where we are hoping to strike links with various other organizations in the EU community, like the Cybersecurity Organization and the AIoTI. So it's all coming together, and it's very exciting time for us. Next slide, Maria. Thank you. So just a quick introduction and motivation of why we are here today. So industrial use of HPC is one of the major pillars of European HPC strategy. We have looked at scientific computing mainly from an academic perspective, but there's a lot of uptake from the industry. And we want to get industrials more and more engaged in HPC. So to that end, what we did a year and a half back is set up a so-called industrial user working group within the ETP4HPC. And the goal was essentially just to get a deeper understanding of what the industrial users actually need. And what we believe is that ETP4HPC is a very strong conduit between the industrial users and EuroHPC. And this is the feedback and recommendation we got from the Commission as well, that we are a very strong liaison between these two organizations. And we address industrial user inputs. We want to get the inputs from the industrial users and make it part of our R&I agendas as well, and primarily the SRAs. So the goals for today is to talk to two of our esteemed guests from Airbus and Thales, and let's just get an understanding of what they actually do. How do they use HPC? It will be interesting to note that, and then we can have a deeper discussions of what are the things that they lack today, what are the pain points, what are their challenges. We want to make a careful note of that as we progress. So with that, so Maria, can I go to the next slide, please? So thank you. So our esteemed speakers today, we've got Thierry Collet from Thales, and Jean-Paul Martinot from Thales, and Jared Butner from Airbus. Maybe Thierry, do you want to say a couple of words about yourself today?
Yes, I can. Sure. Yes, now? Okay, so
yes.
I'm Thierry. Yes, okay. I'm Thierry Collet. I work at Thales Research in Paris, and Thales is a new member of ETP4HPC, and I represent Thales in this in ETP4HPC, and in the activity we manage. I am in charge of all digital activity at Thales Research in Paris.
Great, thank you. Jean-Paul, do you want to go next, please?
Yes, I'm Jean-Paul Martinot. I work also for Thales, of course, and I work in Paris, and I work in a division, in the Defense Mission System division inside Thales, and my activities all that concern modeling and simulation. So we have a certain experience since the 90s with HPC computer and software.
Thank you, Jean-Paul. Jared Butner, Jared, do you want to go next, please?
Yes, my name is Gerd Butner. So I'm belonging to Airbus Commercial, but have a role for cross-divisional CRT, that means for central R&T, and leading a roadmap called data processing, which include HPC, AI, big data, and blockchain across all Airbus divisions. So really working everything what is Airbus doing on the ground, on air, and all these kind of topics. So give an overview of this. From history, I worked since middle of the 90s on all the CC Numa architectures and past, built my own R&T, own parallel clusters, beginning of 2000, lead all the harmonization of HPC the last 10 years, and now moving more to the technology side to shape the future for HPC for Airbus.
Great, thank you. So with that out of the way, I think we'll go to the exciting part now. So let's start. Just start with the introduction. Let's start with some presentation of what the organizations work on, and then we'll go into the discussion. So Maria, back to you.
Maria, sorry, can you share again the screen with me?
Yes. A second. Now you have it again.
Okay, so Thales is a new member of ETP4HPC, and in this slide, you have the activities we address military market and civil market. So in the domain of aerospace, space, ground transportation, security, and defense. And today we will have a focus on the defense activity with Jean-Paul. And after the presentation of Jean-Paul, we will present some next step we want to address all together inside ETP4HPC. Okay, so I leave the floor to Jean-Paul.
Okay, so just a focus on the application of HPC we have in the division Defense Mission Systems. So just a small presentation of the activities of this division, which is separate in 4 lines. The first one is all that concern electronic combat system, so mainly aircraft for aircraft and helicopters. The second one that concern all this what is intelligence, surveillance, and reconnaissance. So mainly radar application. The first line is radar and electronic warfare systems. The second one is mainly radar application. And the 2 other one are above water systems and underwater systems. So the last one is more dedicated to the hardware is more sonar application. So of course, in all this line in hardware development for all these applications, we use simulation and modeling, both for in the design phase, but also in the integration and verification, validation phase. And also to understand sometimes what happens in flight test. So virtualization is of course in the course of the development. In fact, we develop like a digital twin, hardware digital twin of what we are developing. Even if the word that digital twin is sometimes understood differently, but in any case, it's a virtual mockup. And so in the domain of simulation, at the bottom, I put what concerns the technological development, but at the level of components, that means small objects, small parts which doesn't need to use HPC because the problem is not so huge to solve. But when we go up to the equipment, then the problem is much more complex, and then we need HPC to simulate the performance of the sensors or the captors, and also to simulate when in the real environment of the sensor, the performance of its performance. So that means radar in the presence of a radome, electronic warfare systems in the presence of the platform, or coupling between equipment. Which all these areas that are where the color is, I don't know, red or somewhere small red, all that area needs to use HPC computers because the problem is huge. And there is no code, there is no software on the market that are able to solve this kind of problem due to the size. And so we have to say, well, when you look at a radar application, we have to face the problem that we start from the transistor, the model of a transistor, and we need to have a continuous chain of simulation, starting from the transistor and up to the performance of the radar on board. That means in the presence of the radome everything which can have a significant impact on the performance of the radar. So we have to develop two things. The first one is, of course, mathematical methods, numerical methods, in order to increase the speed of the method, speed and accuracy, and also the use of HPC, and so to develop parallel algorithm and parallel software. I think we have lost. I've lost. No. Okay. So next, but I don't see exactly just 1 minute, 1 second. Because I've lost the presentation here. Okay. Okay, I will find it. Okay, so now we are at the slides applications. That's okay. Okay. So what means HPC? We use at the moment we have used a long time ago computers like Cray computers and so on. But in terms of we say production of simulation, we use an in-house HPC cluster, and we use we have a partnership with CEA to use the Cobalt computer at the CCRT, and sometimes the other computer of the CEA, which is in the defense domain. So this is the kind of computer we use. The application is, of course, Maxwell, because we develop RF sensors, radar and electronic warfare. So we use different versions of that solver, which have to be always parallelized, which is the work itself in itself. And of course, it's used in all developments. And the maximum size of what we can deal at the moment is, because Maxwell solver use boundary element methods, the maximum size we can deal is around 100 million of unknowns, which is a huge size, because when you use a boundary element method, the matrix is full, so it's a huge matrix. So it has to be MPI, OpenMP, out of core, all these characteristics have to be taken into account when you develop the solver. So just two examples. One example on the Rb2 radar, which is a radar that keeps, which is mounted on the Rafale aircraft. And so I put just some example. Of course, it's not when you see simulation and measurement, in fact, it represents the distribution of energy in space of part of the radar. And we have a high accuracy, which in both polarization, in fact, in the main polarization of the radar and in the cross polarization of the radar. And this is why it's used, this simulation are used to explain some technical facts that can happen in flight. It's accurate enough to be completely confident in the result of the simulation. And the other examples concerns the axis deviation. It's the fact that the beam of the radar has a deviation due to the radome that has to be taken into account, and also it's a very high accuracy level. Another example which is interesting because because of what is written in the blue part, that we have the choice to different configuration of antennas. It's an IFF antennas, so which is mounted on the search antenna radar, which is a surveillance radar. And the real discriminating factor between different kind of design was the onboard performance. Because if you take them without the platform, there is no difference between the different candidates. And so it's completely necessary, specifically for this kind of function or for EW, to take into account the platform, because the platform participates to the performance of the system. And so this is what is shown at the slide 11. So this system is mounted on an ATL2, which is an old aircraft, which deals with surveillance. And the capacity to perform an accurate computer simulation of the performance of the antenna is very important, because this result is used at the system level to see on scenarios what are the performance of the system, in fact, because you have a real life performance of the antenna. Okay, so I put on this slide some what we expect. It's not the same subject, but what we can expect from I could say a HPC community. So one thing which is very important is to share knowledge. This is very important in the community, to share the knowledge of the different, because the different person in a community that don't necessarily face the same problem due to the physics, they simulate and so on. And so to share the knowledge on parallel algorithm, on tuning, on the software environment, MPI, etc. And to get support, so support on the internet, for instance, which is blog, FAQ, and so on. The other thing is the training, of course, because when we develop, we have to train, and to get information from the people that who are interested in the technical, who are specialists on the technical survey, and on the, which means on the computer that we have to face in I don't know, 5 or 10 years, because this is it has an impact on the software we develop, of course, and on the adaptation we have to do. If we look to the past, there was one time I think in the 90s, computers that have a vector that are based on high importance of vectors with very long vectors. It's not the same to develop a parallel algorithm where you have a vectorization with very long vectors or not. So you have to face the adaptation of your algorithm to the architecture of the computer. And then I let the floor to Thierry to follow on.
Okay, so thank you, Jean-Paul, and just 2 slides to conclude our presentations. The first things we want to point out is the fact that there is strong convergence between IT and OT, and this topic is very strong for us, because in the past we had a few connections between the sensor, sometimes smart sensor, on the HPC or cloud capabilities. So which was connected offline. For the next step for us, we will have a strong connection from the point to point, from the sensor to the HPC, and this is very new thing for us. So we will integrate in our system online capabilities from the digital twin, optimization, decision, reasoning, training, etc., etc. Of course, we increase the capability of the sensor, and in the middle we have a new object called the edge computing at the edge capabilities, able to make some optimization decisions, training, and reasoning. So this is very new for us, and of course the continuum computing is a strong subject for us, and we are happy to see this subject in ETP4HPC. And we just pick up, with Jean-Paul, 3 hot topics for us we want to point out today. The first thing concerning the simulation is the domain of physics-informed neural network for surrogate model. This is very important topic for us. We are working on this topic at Thales RFC, and of course our business unit are very interested for this subject. So this is the first thing we want to work on, and we are working on. The second thing is more long-term, but we need to take into account the capability of quantum computing, and especially to use online quantum processor units. And we have some applications, mainly on the optimizations problem. And we are working on this topic, and we will be very happy to work with other partners of ETP4HPC in order to address this topic. You have in mind that we want to put online the quantum processing capability. It's not for tomorrow, but for the next decade, it may be very, very interesting. And of course, the last topic, last but not least, the continuum computing between the HPC and edge is very, very important for us, and we want to capitalize around the edge computing platform, but we want to be sure that we will be able to address the continuum computing. So this is the third topic we are working on, and we will be very happy to have some cooperation with the ETP4HPC partner in the next European project in order together to address this problem. So thank you for your attention. This is the end of our presentations.
Thank you so much. I think it was extremely informative. It's very good to see the linkage between our Transcontinuum initiative and what you are seeing from a Thales perspective. So I've reserved some questions for you, but we can go over that in the end. So can I request Jared to go next, please? Thank you.
Yes, I think you should see my screen. It's okay?
Yes.
Okay. So I'd like to talk a little bit on HPC and the future of HPC inside of Airbus. So Airbus, yeah, I'll give a little bit an overview on Airbus. What we are doing is different area. You see, for example, this is something what we are doing in all these pioneer areas where we have developed and passed the first dual pilot cockpit, all these vertical tail on carbon fiber, everything on this is ongoing. So we will continue developing our current fleet of airplanes and really improve them for a lot of areas inside of the cockpit to ease the communication with the pilots and so on. There's a lot of things ongoing. There's something what is ongoing a little bit more new is really to make the aircraft industry more green. That means something in the area of zero emission aircraft, something on to really go so looking to e-fuel to make to shape this for the future to make flying aircraft more green than they are for now. This is one of the areas we are working on. There's a lot of things to hydrogen, and you can imagine there's a lot of simulations ongoing for the different new purposes on this area. The second area we are working on is on helicopter side. So Airbus has provided the largest helicopter provider all over the world. So we are doing a lot of future development in this helicopter side, especially to secure the helicopters to support the pilots. What is the really something linked to AI, but I will come later on these, to really have assistance system for the pilot to secure more the helicopters for the future. And the third pillar we talk about is everything what's belonging to defense and space. Defense and space, as you can see here in the portfolio, there's a huge portfolio from the military aircraft for the A400M for the transport aircraft up to the MRTT, the tanker area, the combat aircraft, and also very specific mission aircraft like drones. Then we have the space system in everything what is to launch a rocket together with Ariane inside of the Ariane group, but also all the satellite mission where you have only one shot to do the job right, so you have not allowed to fail. This is really challenging to run a lot of simulation in the backend. The connected intelligence, including cybersecurity, communication technologies in this area, and finally all what is on the unmanned area to really support drones for military and civil areas. It only describes the global thing what we are doing, and also on the connected intelligence you see also all this image recognition from satellite. It's always part of the Airbus portfolio. And to coming back on this, I like to give you a little bit an overview, but only few examples what we're doing because if you see the broad portfolio, it's very difficult to do this in a very general way. Looking to commercial, where I'm coming from, HPC enables the virtualization of aircraft development. That means we have to deal with all the different disciplines at engineering in the aircraft development and operation area. And you can split this in 3 global classes when I look to the different disciplines. Disciplines are everything what you know from classical engineering, the flight physics area, everything what's belonging to the structure area, power plants, all what you need on engines, propellers, on all the important things you have to do in this area, to the systems to fly really a physical aircraft, and then the multidisciplinary optimization. All what you can see, there are, as I said, there are 3 classes of kind of application we are running. Looking to the flight physics, aerodynamics, we have to develop our own code with partners because they're all over the world. Only, I would say, something in the area 6 to 10 customers on this area. We don't have more airplane producers all over the world, so it's not an attractive market for the ISVs, because if you have only 10 customers, you cannot really charge them back, and therefore we have to develop our own codes for the high-speed aerodynamics for civil and military aircraft, as the market is a very small one. So that's one basic class we have to do. Looking to structure or similar tasks like structure or systems, where we see us more as a user of existing products. So using existing technologies and products from ISVs all over the world. And the but is most of these codes, when I look in, is code designed somewhere in the 80s or 90s last century. So there are some modernization done by the ISVs, but it's only small bricks has been modernized. No one really spent redeveloping code based on newest technologies. I know there's a lot of effort behind, but at the end, you miss a lot of opportunities linked to new technologies and a lot of improvement in this area, where we also spend some time on. But globally, it's not our core business, as we see us more as an end user. And the third brick, it's not here on the slide. It's everything what's a link to noise, for example. Acoustics is a huge part. And if you like to run acoustic, you have to understand outside acoustic means you have to calculate a CFD, fluid dynamic calculation upfront was a huge task. And then you create, based on these shock waves, external noise to the airplane. So you have to understand that the CFD program is only in pre-processing program to have noise. A lot of noise you can measure, but you cannot really physically explain what's going on in the noise area. So we are looking for physical explanation, and already a lot of large prototypes or really measuring system to capture where the noise is coming from. And if you're flying an airplane, I think most of you already took an Airbus somewhere. If you are on an airport, you hear sometimes it's like a crazy noise when it's on the parking position, like it's very simple. It's a small hydraulic pump opens the cargo door, and you see it's a small piece you have in, but it gives a lot of noise in a plane. So you have to understand how acoustic is going on inside and outside of a plane. There's a huge task and a huge development to be done. So really, this is globally a key enabler to really make the development most vertical as we can do. But there are a lot of steps to be done on this area. Take an example to flight physics. Flight physics has done a lot to the last 25 years, coming back from physical simulations on the wind tunnel, historically tried to emulate this in a very small scale area linked to the capabilities of a computer, going more for 3D simulations since roughly 15 years, but always in a combination with 2D, because it's too complex to do everything on a global scale. But if we like to go on these, we really like to have a complete physical wind tunneling models available, including laminar turbulence, multidisciplinary optimization, all these to be done. It's a huge task where sometimes you have to develop the methods to do this, and in parallel really run the physical tests. If you go on this, in addition, there is a prediction made with our flight physics colleagues, and you see we are currently on the way to implement a set exaflop system, what is maybe available somewhere. First system I would expect next year in US. But if we look to the expectation of our business is they start talking about a setaflop system, what is maybe a decade up front from us now. So really a lot to be done in this area. And their dream is really fly a vertical aircraft by equations. That they like to do. You see, can see a lot of bricks to be done based on technologies they like to implement, but there's a lot of things to be developed in the theory area. Don't know why it doesn't move. Do I lost you, or don't know why?
I hear you. I hear you, Jed.
Okay, that's fine. But I lost a little bit.
We can still see your slide. You're on page 11.
Yeah. So okay, sorry. Problem of electronic system. So, but there is another subject coming on. It is the manufacturing simulation. The manufacturing, is a growing area in this. We have the first step where we more or less more mature or improving these is, we call it vertical integration, to have an end-to-end process from enterprise resources over manufacturing execution on the shop floor systems, all the devices in. This is something to be integrated. You can call it IoT Industry 4.0. So this is something what is ongoing. We know since longer time, but there's something to be improved on the horizontal integration, really have the end-to-end integration from an engineering point of view up to the final product in service and to be operated in service, also capturing all the information in a digital way in between. And the last step, and that's what we are currently targeting in a lot of products we are going forward, is really have a full manufacturing simulation. That means have a virtual twin, and a virtual twin, a digital twin for the whole environment means the factory together with the product together, and this in a physical and in a virtual way in parallel. So there are multiple virtual twins we have to develop, and we have to consolidate all the informations in between. There will be a lot of simulation requirements coming on based on the huge amount of IoT data you need to feed with these kind of systems. Now we're coming to the future challenges we see from Airbus side. There is one, if I see these upcoming IT technology change, we will have, and that's all you can see already on the market, coming up more and more diverse systems. And the question for an operation companies, how to schedule this heterogeneity of hardware in application in large production environments. Because you have a lot of hardware, you have a lot of different kind of hardware, you have a lot of different kind of application with different requirements, but you have to scheduling everything in more harmonized way. You cannot build an environment by application. As Airbus, as you have seen before, we are running in the HPC area, something in the area of more than 60 applications. How to do this? And they have already a lot of specific requirements. And this is a growing area if we take into account IoT and everything around this. So, and also coming up to AI, and that, but this will on a later slide. So these kind of integration in specific environments, this would create a challenge where you have no good idea, or we are start working on, but we need some support how to manage this in a global way. The second one is what will come up after middle of this decade. We know Moore's law is close to the end. If you see the maps from the TSMC and all the other large vendors coming on, you can see that after middle of this decade, there will be no future shrink where we lived from the last 20 years on of the hardware. So we will have specific processors, which I mentioned before. This has to be done and to be optimized by application. But then how to manage all of these? And global the question, it's to the academia area, what will come up in future after middle of this decade? We are looking in this, we are also testing in this, will be seen on the next slide. But at the end, this is a huge development done because the view, long-term view is missing. A long-term view means also to be linked with an aircraft. An aircraft has a lifetime of at least 20 years by an airplane when it's built and delivered. So to deliver and develop an airplane takes roughly 10 years. So when I start now, I don't know which is the system which is available in 2030 when I start now with the development. This is some challenge we are facing, and this is not a short-term view we have to do on this. The second area in the software side, as I mentioned before, how we deal with AI-inspired simulation in an AI and an HPC infrastructure. For AI, you have typically, you use a lot of cores, you have typically small data sets in, you have to combine this with large simulation, dealing originally with very large data sets. This creates a lot of challenges to the ecosystem behind that, means to the storage side, how to get the data fast enough to the systems, that's network and so on, everything on this kind of management and this, and how to combine these really on combined kind of systems where I see, or we are working on, and I see something coming up more and more, but it doesn't mean replacing simulation by AI. Therefore, we talk about AI-inspired simulation. It's a combination of both, learning from past experience and improve simulation by this. For sure, we have mainly from our side end users, which have a lot of knowledge on the technical side, but they are not HPC specialists. So it should be done seamlessly from their side without a lot of knowledge on this. And this is really a challenge to simplify the more complex IM landscape or IT landscape for an end user. Last, where the Airbus is working on since several years, it's what's going on the quantum computing area. I finished first project on quantum computing for Airbus 2016. So we are more than 5 years on this already ongoing. But we have to adapt, and that's a lesson learned, software and problems to quantum computing technology. You may have seen there was a quantum computing challenge launched in 2019 to the worldwide quantum computing community. We had the nomination of the winners in the Q2B conference 10th of December last year by our CTO, Grazia Vitetini, and Mark Fisher, it's the head of flight physics. This was more a branch led, mainly linked to flight physics problem. And you have seen this flight physics problem formulated in mathematical and technical way. We continue working on this. We also continue with working of some of the finalists and with additional proposers in this area of the quantum computing technology. That is something where we try to shape the future to be prepared to have algorithms available. And that's for me the new challenge, because the algorithm has to be totally redefined and rescheduled for this kind of problem. This is something where may some support is required from the research area and really also to the application area there. I know what's ongoing there. We're animating a European network for this with one of our colleagues. So there we do already a lot in this area, but potentially there could be something more and specifically to the application area and not only to the physical development. And finally, there's one thing what I mentioned in the beginning. Sustainability is one of the main targets at Airbus side, and really spend a lot of energy to create something planes on e-fuel or zero E, however you call it. And that doesn't mean sustainability. It's not the CO2 footprint, it's really the sustainable footprint. Discussing if you use the nuclear industry and nuclear energy, it will have an impact on sustainability for 100,000 years at least. How to compare this with CO2 footprint on carbon side for now. So there is a lot of requirements ongoing, and to see how we can improve this area for a sustainable IT and HPC environment in future. That's more or less what I like to share with you. Hopefully I'm more or less on time, and thanks for your attendance.
Thank you, Jared. This is perfect. I think we are very much on time. It's very interesting that you mentioned that you have requirements for Zetaflop capabilities as well. We are still getting to grasp with exascale and exaflop systems, but it's really, I think, an eye-opener for many of us that there are industrial use cases that are looking even beyond that. So that was very interesting. Thank you. So let me start taking questions then. So Maria, is it okay if we start going into the Q&A now?
Yes, please.
Great.
Can you see the questions?
Yes, so let me start looking into questions from the audience here. So yeah, let's start with questions from Jesus Ramos Rivas here. A question for Airbus. So the question is, how do you benefit from exascale? I think you mentioned some points there. I'm sure you can elaborate on that. Are your applications able to take advantage of such a high level of parallelization? So it's a good question. So any thoughts, Jared, on that?
Yes, I have to differentiate the answer. Yes, thanks for the good answer. It's a very good question. What I see really on the area of the CFD, I think we can really leverage on the exascale technology, which we are developing application which should be scalable in the area of 100,000 cores by execution for one problem. This is really relying on exascale technology. But what I also mentioned, the ISV code, when I look in the classical area, there is a huge improvement to be done, because most of the system you can solve on a single system. You don't need an HPC system based on the missing improvement and development to new technologies on these kind of ISV codes, and that's really missed. Looking on the classical problems in the funded element area, everything what's going on in this field there, I know there are new technologies ongoing. I know a lot of new mathematical models available, but not implementing from ISV side. As we said, we are here a customer on this from Airbus side, but not globally. So yes, exascale we can have benefit in some areas, but unfortunately some of the problems are not really dealing with exascale technology. For sure, there are bricks in like I/O and so on and networks where we can have benefits, but that's minor subject logically on this.
Thank you. So let me see if there's any more questions here. So I have a question for Thales on education and training. So it looks like you mentioned one of the things that you really are looking for is education and training, and you need more knowledge in some of the things that you would like to do. And so do you want to tell us a little more about it? Because for example, there are already initiatives such as Jean-Philippe's education and training with, I mean, there's some initiatives that are looking at education and training more holistically. and there have also been events that focus on education and training needs from an industrial perspective as well. So can you tell a bit more about what you need from education and training perspective? So it'll be good for us to take some notes.
Yes, small word, but in fact, when you look to young engineers coming directly from school, it's not often that you find it difficult to find people who have a high level of education in the domain of HPC, which I mean both algorithm, people who are knowing algorithm, parallel algorithm, architecture, what is an HPC computer, how I can implement any algorithm or some kind of algorithm on this computer. Generally, it's very rare to find people directly coming on the market from the school. So I think we need to train them, and we as developer inside Thales, which is always a small team. You have not we have not a team of 100 persons developing parallel algorithm. So we need somewhere an area where we can that can train or educate and so on parallel computers or parallel on HPC, where we can send the young people to have an add-on from their education. This is very important, I think. Second one is you always need training all your life. So your life you have to update your knowledge, and it's not enough to do it yourself. It has also you have also to find a kind of community, which is one of the interests of the CCRT. But you have to find a location where you can exchange somewhere which people facing the same kind of problems, of problematics, and so on. This is very important. The sharing of knowledge and difficulties and problems and so on is very important, I think.
Thank you so much. Jean-Philippe, do you want to add some? I'm sure you had some comment there. Go ahead.
Thank you, and if I may add very quickly, Jean-Paul mentioned CCRT that was briefly showed on one of his slides. Just to remind people, this is this dedicated computing center we have at CEA for industrial use of HPC, and it's a sort of club of nearly 20 industrial users, advanced users of HPC, including Thales, but many more. And like Jean-Paul said, one of the strengths of this club and a real strong added value is the sharing of experience, joint technology watch, and to some extent some training activities. This could be further developed, but this is already a very good basis we have with this kind of setup. Okay, let me now maybe quickly go to a couple of other questions that are coming. For instance, it's out of order, sorry about that. Quantum computing for Gert. Thierry made a good mention of their interest in some aspects of quantum computing, but we have a question about the potential of quantum computing for Airbus, and in particular, or including, but maybe not limited to, quantum annealing. So that's a question for you, Gert.
For Airbus, so we know, or we have some currently unsolvable problems with classical systems. Everything what's called multi-dimensional optimization, the problem become easily too large to be solved with classical systems. So there's an opportunity for quantum computing system. Now, another area where we discussed about, or we had already piloted, it's something like fault tree analysis. If you know fault tree analysis, if you go to a lot of levels, and this is something linked to security of an airplane, there could be easily unsolvable problems. You can go up to 6 to 7 limits on classical system, but then you're coming up to a resolving time depending on the precision you like to run, which is going to the age of years to get a problem solved. So there is something potentially quantum can help in these kind of problems. We're looking in other areas for, it looks simply, but loadability of an aircraft. You have only 20 minutes time to find a solution. You can do this classically, but it takes 2 days to do it classically. So why not try to find the minimum with the probability and these on the quantum algorithm? That's part of the quantum computing challenge. We're looking for potential replacing CFD kind of solvers, what is Navier-Stokes up to now, by other kind of algorithms and areas to make CFD faster. To avoid that, we have to go to setaflop systems. Only gave you a set of ideas where we are working on.
Yeah, so maybe I can ask a couple of questions. So I'm grouping some questions here. There's many questions coming. What are the characteristics of the edge? And there's also a question about how much of HPC will be needed on board the planes. Like, will you be running a digital twin on board? So hopefully, maybe Airbus, and maybe it's probably a question for Airbus, but we'll also see if Thales has some comments on the edge aspect. Jared, you want to go?
I can start on this. So on a plane and also on all flying equipment, it's a totally different kind of problems, because most of the systems you have on planes are single core systems far behind what we have on ground. And this is linked to the requirement and safety requirements. All the systems we are running classically are speculative system. You have prediction of caches, filling cache to get time in an answer in time, and so on. But you have to guarantee, if you have a flying system, you have to guarantee an answer in a very short time. And to guarantee with a prediction system doesn't work in reality. So therefore, we will not have something on this. Maybe we have some support system in lower areas, but we are developing, that's nothing what I'm working on, but we are developing our own computer system for flying equipment together with some partners. That's not one I'm in, but I know I'm working very close with colleagues in this area.
Thank you. Jean-Philippe, do you have any questions you want to ask from your side?
Not on my side, but I see we have still a few pending other questions in the list. But yeah, let me pick up this one. I'm trying not to forget anybody, but to tell us this time about Continuum, which seems to be requiring very good connectivity. And what would be your view on this issue, Thierry?
Okay, so concerning, of course, the continuity, we will take into account of the capability of course, the 5G technology will be very interesting for in order to manage this continuity, but it is not only wireless, it is wire technology. So this is something we have in mind. We are working on, and we have a specific regard on the 5G technology, because it seems to be something very disruptive for such a capability of connecting HPC and edge computing. But not only, there is other technology and some technology like the internet and with a high level of security like the TSN. So okay, we look after all this technology in order to find the best solution. But we have in mind the 5G as a very good new challenger in this domain.
Okay. We have a question on data analytics and possibly in situ visualization. Either Airbus and or Thales. Would you have a short word on this in addition to, I would say, core hardcore computing itself?
Okay, the question is about the data analytics.
Yeah, how strong is the subject of data analytics and data management and possibly in situ visualization for you around or inside HPC?
Okay, so I can comment from Thales and in situ, the data analytics is we want to be able to have this kind of capabilities in the edge computing. So this is the first things, and the other thing is not only the visualizations, but we want to be able to help the user of our system with a lot of capability of interaction with the system. So it is not a data visualization, but we need to be able to have a very convenient interface between the user and the system with a lot of AI, with a lot of capability of explainable AI and decision aid system in order to be sure that at the end we will give the best help to the user for using this technology. So it is not only a problem of data visualization; it's a problem of interface between the system and the intelligence artificial algorithms in order to use these capabilities with a high level of capabilities.
Yeah, I fully agree. And when I look from Emma's point of view, to say it very simple, if you see a plane is a huge IoT device which creates by flight terabytes of data. If you you cannot download in flight because it's simply not possible from bandwidth point of view. So you have to aggregate the data and download somewhere on an airport when you are landing this data, but then you have to analyze the data. But this is more data management and connectivity throughput problem than an HPC problem. Data transfer is sometimes more time expensive than the real analysis of the data.
Great. So just maybe one question, Jean-Philippe, if I can pick this up, is maybe many of the partners will be interested. So would both, maybe this is the last question perhaps, so would both Thales and Airbus, are you open to participate in research projects with other community members in the EU to achieve some of your goals for your work?
Yes, of course we are interested to participate to European project and the topic we present to you. Of course, we will be very happy to work with other partners to share our use case in order to be able to increase our capabilities to address the problem we present. And it is important for us, as Jean-Paul said, for the community of users of HPC. So the best things to improve this capability of communications and work together is to have common project together.
And I agree on this also from Airbus side. And you may aware on European level, there's a proposal, a call ongoing called Clean Aviation. And Clean Aviation is for sure, we already proposed a large project in this area. And that's also one area, but then we are very open for other areas, really for collaboration. And we do this already. So there's a lot of projects ongoing where we are participating.
So I think, Jean-Philippe, we are over the hour now. So
yeah,
we probably need to, unfortunately, we can't handle any more questions.
Could it be a very last one?
Sure, go for it. Yeah, one more. Yeah.
And then we conclude because, and I hate to not to process all the questions from the audience, which has been extremely active.
Yes, please.
Today. Yes, maybe it's a good way to conclude. There is a question about COVID impact on R&D activities by themselves and investments in the, I would say, future perspective. I think it's a question for both Thales and Airbus. if you have a few words on that to conclude. It's a tricky question, maybe, but
I can make a comment about COVID. When we faced in March last year the fact that everybody has to go home, one of the questions is, okay, are we able to continue to work with a lot of people going home? And then we face the fact that we were a little bit under-equipped in terms of homework. So in terms of connectivity, in fact, and the capability of all the tools we have inside Thales to face the problem of connectivity to people who are at home. So there is a lot of improvement because it has a direct impact on the work and consequently on everything that is relative to the work, business and so on. And so we have to improve our tools and also we face the fact that one thing which happened around HpC Webinar, for instance, is that the tools which is used to make this webinar is not allowed inside Thales, for instance. So imagine that between our partners, we have the same kind of problem. We have a lot of partners which we have to organize video conf and so on. And there is not so much tools that there is no, how I can say, a common tools or which is allowed by quite all partners. So there is something which is which was highlighted by the COVID, in fact. This is by one of the COVID.
For me, from Airbus side, there's something really ongoing for the COVID to more secure aircraft in the COVID area. You may don't know, maybe you know, in an aircraft you have already filters in, and that's by definition since decades, which have deliver air quality like a chirurgy room in a hospital, and you have a turnover of the air inside of a plane by, I don't remember, 2 or 5 minutes by 100%, and really run simulation on distribution on this area. For sure, this is something ongoing in Airbus, because to think about what could be the impact, how to secure at most, and there is also some algorithm you can play your own. If you put on the air conditioner on top of your seat, by 100%, you can reach only some centimeter of any virus in front of you. It really secures you and maybe also all the other passengers. So this is really simulations ongoing in Airbus on all of these, and maybe some rules will come up very soon, but that's to be discussed with the aircraft agencies.
Okay, thank you. But maybe Sai, Maria, leaving the floor to you.
Yeah, I think, thanks. Thank you so much, Jared and Thierry and Jean-Paul. It's extremely enlightening and very useful today. I wish we had more time, but we had a lot of inputs to actually digest. So Maria, back to you. Any concluding words from your side on next events and etc.?
I also would like to thank you for all the speakers, as also for you, Jean-Philippe, Sai, and Pascal, for your help. And I would like to ask everyone to please fill in the survey once you leave the webinar. We went over a little bit of time, but many of you stayed with us and you had very interesting questions. We hope that you don't mind this. You will receive the follow-up email with the link and with the slides of the presentation on Monday. And here you can see the links to our next 2 webinars. The one is on 28th of May with Maluxina. This is the new HPC system in Luxembourg. They are finalizing the installation right now, and the system will only operate from May. And the next universal user related webinar will be on the 18th of June. That time you can get familiar with the SME's perspective. NAG and Castelcom will present their experience with using HPC. And I'm on behalf of ETP4HPC and our presenters, I would like to thank you for joining us today. We hope to see you again on our future webinars. Bye-bye.
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 Have a nice Friday. Bye.
Bye-bye.